Okay, so this is a short video on Newton's second law, F equals ma. There's equations, questions and answers at the end, and as well as that, if you need any extra resources, don't forget there's a link below. As well as that, don't forget to subscribe and like. So starting with some definitions. Force is measured in newtons. It's an interaction which can change the velocity of an object. Newton's first law, which can come into some of the force questions, any object will remain at rest or with constant velocity unless acted upon by a net external force. And Newton's second law, the rate of change of momentum of an object is equal to the applied force. Momentum is mass times velocity. So the rate of change of momentum, F equals the change of momentum. Rate of change is anything divided by time. Well, we can expand this to give mv, the final velocity, minus mu. So that's the final momentum. Take away the initial momentum. Don't forget it's the rate of change, so it's over time. We can take out mv minus mu over t, which will give us mv minus u divided by t as our new equation. And this is equal to the acceleration. So we get F equals ma, which is the equation that we all know for Newton's second law. Newton's third law, if object A exerts a force on object B, then object B also exerts a force on object A, which is equal in magnitude but opposite in direction. I'll do another short video on that one. So here are the questions. There's 3 of them. If you want to have a go at those questions, please pause the presentation now, but I'll go through them in a second or two. So, the first question, a cyclist of mass 70 kilograms accelerates from rest at 2 meters per second. Let's just note that this could also be written as 2 meters per second squared, which is also the acceleration, or 2 meters per second times 2. All those 3 ways of writing it are correct. What driving force are their legs applying? Well, we've got kilograms and meters per second, so we've got the correct units here. So we use F equals ma, and we get 70 times 2, which equals 140 newtons. Fairly straightforward. Possible marks could be 1 for the equation, 1 for the substitution, 1 for the numerical answer, and 1 for the units. So possibly 4 out of 4. Give yourself a mark out of 4, please. A lorry of mass 6.3 tons brakes with a force of 15 kilonewtons. What is the lorry's deceleration? Okay, so we're just going to use the F equals ma equation again, but we have to change 6.3 tons, that's the mass, to kilograms. So it's 6,300 kilograms, that's the mass. And we've got a force here, and the force is 1,000, no, it's not 1,005, it's 15,000 newtons. 15 kilonewtons is 15,000 newtons. So now I'll put the numbers in the equation. I'll just write my equation as it is to start with, because that ensures that I will get the substitution mark. So I'll just put the numbers where it says. So I've got 15,000 equals 6,300 times the acceleration. Now, if you'd written 15 kilonewtons here and you'd written 6.3 tons there, you would still get a substitution mark because you've written the numbers in the correct place. If you wrote 6.3, you wouldn't get the mark, perhaps because it's 6.3 tons. So you'd have to say 6.3 tons if you don't know how to change tons to kilograms. Now we rearrange it, so we get A equals 15,000 divided by 6,300. And the answer to that would be 2.3809 meters per second. However, if I leave it like that, I won't get the correct answer because I need to check back and see what significant figures are in my question. And I can see here I've got two significant figures for the tons, two significant figures for kilonewtons. So I need my answer to be in two significant figures. So I get 2.4 meters per second per second. And it's asked for the deceleration. It's slowing down because it's applied the brakes. So the deceleration is 2.4 meters per second. If it had asked for the acceleration, I would have had to have put a minus 2.4 meters per second. Okay, on with the last question then. Starting from rest, a car accelerates to 9 meters per second in 4 seconds. The mass of the car is 1.2 tons. What force does the engine apply? So 1.2 tons, I can change that straight away, because if I write this somewhere on my answer sheet, then I will get a mark for that, even if I can't do anything else. Well, to use F equals ma this time, we need to work out the acceleration. And A equals V minus U divided by T. So the final velocity is V, that's 9, minus the initial velocity. Well, it says from rest is 0, divided by the time, which is 4, which gives me an answer of 4.5 meters per second. Now I've got the mass and the acceleration in the correct units. I can use the F equals ma equation. F equals ma, I'll write that down, and I'll get 1,200 times 4.5, which equals 5,400 newtons. And that's my answer. So let's see where the marks will come from for the last two questions then. So I definitely get 1 mark for changing the units. So that's that one in the last question. I'll get 1 for my acceleration, 1 for the equation, 1 for the substitution, 1 for the numerical answer, 1 for the units. So potentially in this question, there could be 1, 2, 3, 4, 5, 6 marks. Maybe even 7 for that. I'm not too sure if that would be on there or not, or if it would make part of a separate question leading into this to make it a higher standard. The middle question, 1 mark for the units, 1 mark for the equation, 1 mark for the substitution, 1 for the rearranging, and 1 for the correct answer to the correct significant figures, and 1 for the units, which makes 1, 2, 3, 4, 5, 6 potential spots where there could be marks available for the middle question. I hope you found this useful and helpful. Don't forget, this was Newton's second law, F equals ma, and if you want to find any extra resources, you can look down below and follow the link to my page on the Times Education supplement. Thank you.